All right, folks, this week we are going to be finishing up our work with functions. And we are going to finish up that work by revisiting two of the terms we talked about early on, and those are domain and range. Today, we are going to be working on finding the domain of a graph. So that's going to be our focus for today. We're going to talk about just domain, and you are going to be looking at finding the domain of a graph. Now, what we need to do here before we get started is take just a moment to remember what that word means, okay? So when we talk about domain means the set of all x values or inputs for a function. Now, what's really important for you to kind of keep in mind today is that you need to be looking for all of the x values, all of the possible x values for each of these graphs. Okay, so x is going to be your main focus for today. Now, just kind of get our bearings here and make sure we are kind of on the right track. You all know that since you're going to be looking at graphs, that the coordinate plane is going to play a role here. And what we need to remember is this axis is the x-axis. And the x-axis is what's going to give us the domain. Okay? Tomorrow we will actually be focusing on range, which is the set of all y values. So this is my y-axis, and it will give me the range. So for today, while you're focusing on domain, what you need to keep in mind is that this axis is the only one that's going to matter to you. The x-axis is the only thing that you're going to use as you're identifying the domain. So domain is the set of all x values, and we're going to use the x-axis on our graph to help us get that. All right, so what I have here are some graphs, and we are going to use these graphs to talk about how to find domain. Okay, so I want you to keep in mind here that for this graph, you'll notice I have this nice graph here. This is a nice, neat circle. This, by the way, would not be a function, because remember, he would fail the vertical line test. If I look at a vertical line on this graph, it's going to come in contact with my circle at two different places. So that means that this graph would actually fail the vertical line test. It would not be a function. We're still, though, going to go ahead and identify its domain. So to identify the domain, I want to know all of the possible x values that this function is using. So I'm going to highlight my x-axis, because that's all I need to focus on right now. Now, here's what I'm going to do. We know that this circle is made up of an infinite number of points. So what I'm going to do is I'm just going to go over here to my circle, and I'm going to choose a point that's on the circle. I'm going to pick this one right here. Now, because that point is on this graph, I know that it has an x-coordinate and it has a y-coordinate. The x-coordinate of that point is a part of the domain for this graph. So here's what I'm going to do. I'm going to pick this point, and what I'm going to do is trace this point back to the x-axis. So what I'm going to do is I'm going to start at this point right here, and I'm going to go straight down and see where I would land on the x-axis. And what you see is that you would land here at 0. So that means that the number 0 is in the domain for this graph. All right, let's pick another point on the circle. So let's pick this point right here. Okay, if I pick that point right there, and again, trace it back to the x-axis, I'm going to land at 1 on the x-axis. So 1 is also in the domain for this graph. If I move over to this point, and again, trace that point back to my x-axis, I land at 2. So 2 is in the domain for this graph. If I move over here and pick this point, you'll notice that I don't have to trace that point back to the x-axis because it's already on there. So the number 3 would be in the domain for this graph. Moving back this way, if I choose this point on the circle, trace it back to the x-axis, I get -1. So -1 would be in the domain. Go to this point, trace it back to the x-axis. -2 would be in my domain. And then again, I hit this point right here that is on the x-axis. So -3 would be in the domain. And then, of course, we have the bottom half of our circle. So if I go here and trace this point up to the x-axis, here, trace the point back up to the x-axis, here, back up to the x-axis. And notice this also kind of emphasizes to you why this is not a function, because all of these points right here that are on the x-axis that I've marked would have a repeated number. So that makes this thing not a function. So we can see here that -3 and -2 and -1 and 0 and 1 and 2 and 3 would all be members of the domain of this function. But you know, what we also have to keep in mind is that the points that I've chosen on my circle are not the only points that exist. So just for example here, between this point and this point, I could put a point right here on my circle. And I could trace that back to the x-axis, which would put me at about a half. I could go in between these 2 points and pick another one. Trace back to the x-axis. And you know, that would certainly be a fraction or a decimal. You know, so one of the things I want you to see here is that starting from these different points on this circle and tracing myself back to the x-axis, I could get not just those nice pretty whole numbers, but I could also get all of these fractions and decimals that exist in between those whole numbers. And then I could repeat that as well for the bottom half of my circle. So I want you to notice what I'm doing here. I'm looking at the fact that for every single point that's on this circle, I can trace that point back to the x-axis, even the ones that are not nice, pretty whole numbers. So I think what you can see from this is that your domain for this circle would start here at this point. Let me use a different color to kind of emphasize this. My domain for this function would start over here at this point. And it would end over here at this point, and it would include all of these x values in between. So if I take every single point on the top half of this circle and every single point on the bottom half of this circle, and I trace them all back to the x-axis, I'm going to end up with this section of the x-axis being my domain. Okay, now real quickly here, you know, you see that this part of the x-axis over here is not included. That's because, just for example, that x value right there, I can't trace that back to the circle because the circle's not there. If I come over here and look at this x value, again, I can't trace that back to the circle because the circle's not there. But if I take all the points on the top half of the circle and trace them back to the x-axis, and all the points that are on the bottom half of the circle, and again, trace them back to the x-axis, what I see is this part of the x-axis right here would include all of the x values on this circle. So that part that I just shaded in blue is my domain. Now, what we're going to do here is we're going to write this domain using the interval notation that we learned about earlier in the semester. So remember, when you're doing an interval, this right here, this part that I've outlined in blue is a line segment that starts here and ends here. And when I do my domain, when I write it in that interval notation, I want to use those two numbers. So start with your number on the left. That number is -1, -2, -3. And then I want to go all the way to this number on the right, which would be +1, +2, +3. So my domain for this function is going to be -3, +3. And then remember that we use brackets or parentheses to complete our interval notation, and that's all based on whether x can actually be that number or not. So I see here that x can actually be -3, and that x can actually be a +3. So for that reason, I would put a bracket on -3, and I would put a bracket on +3. So when I write my domain, when I write this for my domain, what I'm saying is this particular graph has x values that start out at -3 and that go all the way up to +3. So this domain would include all of the x values from -3 all the way up to +3. So all the numbers in the middle. And these brackets tell me that -3 and +3 are included in that domain. But I want you to notice what we did here. We figured out this domain by tracing every single point on the graph back to the x-axis. Okay, so there's that one. Now, let me just say here real quickly that finding domain on a graph tends to be something that sometimes people struggle with. So, you know, this is one of those places where you folks who are at home trying to learn this, you folks especially who are 100% virtual, you are not going to step foot back in this room while we're learning this. You all are going to need to communicate with me. And if it's not making sense, you're going to need to let me know. We can Zoom or whatever we have to do to straighten that out. But certainly ask all the questions you need to ask, because I expect questions on this. All right, so here is another graph. And what you'll notice when you look at this graph is that at each end, you've got these open circles. Now, we've seen that before. And what we know is it means that number is not included. The x can't actually be that number. All right, but this is kind of the same thing. If I want to find the domain for this graph, I need to determine all of the x values that this graph uses. So to do that, what I'm going to do is I'm going to choose a point on my graph. So I could pick this one right here, that lowest point. And what I'm going to do is trace that point back to the x-axis. So I want you to notice that that x value is between 0 and -1. It's a fraction, it's a decimal, but it's definitely a part of that graph. I could take this open circle and again trace that back to the x-axis. That would land me at -2, or not -2, +2. +2 though actually wouldn't be a part of the domain. So I'm going to put an open circle right there, because I have an open circle on my graph. And again, if I go over to this other end, here's another point that's on this graph. I could trace that back to the x-axis, which would land me at what? -1, -2, -3. So that's -3, that's +2. So, you know, right now I've identified 3 numbers that are in my domain by tracing those points back to the x-axis. But what I want you to keep in mind is that for every point on this graph, I should be able to do that. So all of these points would trace back to this area. And then if I come over here, all of these points on the graph on this section would trace back to this part of the x-axis. And continuing on, these would all trace back to that part of the x-axis. But then I run out of points. Over here, the graph doesn't exist, so I can't trace anything back to this part of the x-axis. Same thing over here. There's no graph over here, so I can't trace that back to the x-axis. So what I want you to notice is that when I trace the points that are on this graph back to the x-axis, that what I end up with is a situation where I'm starting out over here at -3 and I'm ending over here at +2, and I'm including all of these numbers that are in the middle, that are in between. A point on the graph traces back to all of this section of the x-axis. So all of those numbers from -3 to +2 on the x-axis are involved in making this graph. A point from the graph will trace back to all of those values. So again here, when I go to write the domain of this graph, I would start over there at the left with -3. And I would end over here at the right with +2. So I'm saying the domain starts out at -3, and that it includes every number from -3 up to +2. And this time, -3 would get parentheses because there was an open circle at -3, saying x can't actually be a -3. And then the same thing over here, that +2 would get parentheses because there was an open circle at that +2. But notice that finding the domain involves taking the points that are on the graph and tracing them back to the x-axis so you can see what x value they are actually using. All right, here is the next graph I want us to take a look at, and you'll notice that it's a straight line. Now the thing that makes this particular graph different, I want to talk about this for just a second. We're going to do domain, so we're going to trace the points on this line back to the x-axis to see what we're using. But what I want you to notice is this graph, this line, has arrows on the ends. The two graphs that we did prior to this had no arrows. They had a definite starting place and a definite stopping place. We know when we see arrows on a graph that means that it goes on. So this line doesn't stop here. It's actually, let me get my black marker here. This line is actually going to continue on forever. So I want you to notice that he's going to keep moving up, and he's going to keep moving to the right, and he's going to do that forever. Okay, likewise, over here at this other end of the line, we see an arrow. And so what that means is we're not going to stop there. What that means is this graph would actually continue on forever. And I can't go quite as far with that one, but I want you to notice that that end of the line will keep going to the left and keep moving down forever. Now again here, if I want to figure out the domain for this line, then what I need to do is think about if I trace every point on the line back to the x-axis, what x values would be in use. So take this point, trace it back to the x-axis. 0 is in the domain. Take this point, trace it back to the x-axis. 1 is in the domain. If I move over here to this point and I trace it back to the x-axis, that puts me at 1, 2, 3, 4. So 4 is in the domain. If I go right here, trace it back to the x-axis, this number is in my domain. That would be 1, 2, 3, 4, 5, 6. But then I have to keep in mind this x-axis could keep going. So I could take this point right here and trace him back to the x-axis. That number, whatever it is, would be in the domain. This number could be traced back to the x-axis. That number would be in the domain. And that would continue on because that graph's going to keep going up and to the right. So I could keep extending that x-axis and keep tracing that line back. On this side of things, if I start at this point, I can trace that back to the x-axis. So that would put -2 in my domain. If I start here and trace back to the x-axis, that would put -4 in my domain. If I start here and trace it back to the x-axis, that would put -1, -2, -3, -4, -5, -6 in my domain, but it doesn't end there. This x-axis keeps going. So I could come down here to the line and trace it back to the x-axis. I don't know what that number is because I'm off the grid now, but I could keep doing that. Now here's what I want you to notice this time. All of these, I've done a selected few points, but all of these other points that are on this line, I could start at each one of those and I could trace every single point back to the x-axis. And since this line is going to keep going, and the x-axis is going to keep going, how long could I continue doing that? Well, I could continue doing that forever in both directions. So over here to the left, I'm going to be able to keep tracing my line back to the x-axis, and then over here to the right, I'm going to keep tracing my line back to the x-axis. So I hope what you see on this one is that the domain is going to be everything. This line is going to keep going to the left, it's going to keep going to the right, so I'm going to continue to add new points that can be traced back to the x-axis. So on the left, my domain would go to negative infinity. On the right, my domain would go to positive infinity. And you will remember from our discussion of interval notation that infinity always gets parentheses because it's not an exact amount. You can't be equal to infinity. So this is a domain that would be infinite because of the fact that this line goes to the left forever and it goes to the right forever, which means that I will have points forever that can be traced back to the x-axis. So this line actually uses every single x value to make the graph. All right, notice on this one, again, we have these arrows. You can see over here at this side of this U shape, it's kind of skinnier. And then as we go to the left, it continues to get wider. So this is going to the left forever and up. So that's going to continue on. And this is going to the left forever and down. So this end will keep doing what it's doing. It's going to keep going up and to the left. And this end will keep doing what he's doing forever, to the left and down. Now again here, if I want to identify my domain, then what I need to do is take the points that are on this graph and trace them back to this x-axis. So starting right here, I can trace it back to that point right there, which would be a positive 2. Notice that 3 and 4 and 5 not going to be in the domain this time, because if I look above and below that 3, the graph is not there. I can't trace anything back to the number 3. Can't trace anything back to the number 4 because the graph is not there. But then moving on over, notice all of these points on this U shape can be traced back on this top half, can be traced back to the x-axis. And by the way, you don't have to sit and draw all these lines. I'm doing it because I need you to see how this works. Now, I want you to notice that I'm getting over here towards the left side of the graph, and here's this arrow. So even though I am now on the edge of my grid, I know because of the arrow that things are not going to end. That graph is going to continue on. So I'm going to continue to be able tracing points back to my x-axis. And then notice on this bottom half, I got the same kind of thing going on. Every point on that bottom half can be traced back to my x-axis. Well, and I quit, didn't I? And so even when I get right here and I reach the edge of my grid, because the arrow keeps going, I'm going to be able to keep doing that. Now, how long am I going to be able to keep doing that? Well, forever. Forever. So when I go to write the domain for this graph, work left to right. On the left, we're going forever. So that would be negative infinity for the domain. And on the right, we stop over here. We stop at 2. The negative infinity would get parentheses because can't be equal to infinity. The 2 this time, there was no open circle there. So the 2 would get a bracket. The x can actually be equal to 2 because there was no open circle there. So the domain on this function would start way over there at negative infinity because it goes to the left forever. And then it would include all of the numbers from negative infinity up to a positive 2. So what you're doing here when you write this domain is you're saying the domain starts here, ends here, and includes all of the numbers in between those two. But notice how we're doing this. We're doing it by tracing our points back to that x-axis. All right, same thing on this one. This arrow is going to continue going in the direction he's going, so he's going to continue going right and down. This arrow is going to continue doing what he's doing, so he's going to continue going this way, to the left, to the left and down. So again here, let's identify our domain by tracing all the points on this V-shaped graph back to that x-axis. So this top point would go to there, and then as I start moving to the right of him, all of these points are going to trace back to the x-axis. And then I'll do all of these over here. Now, I'm at the edge of my grid, but notice this arrow would keep going. So I would extend the x-axis and I would be able to continue tracing points on the V back to the x-axis. For how long? Well, forever. Okay. Then I could go this way. And you'll notice here I get to my arrow, but I know this is going to keep going. So even when it looks like I'm done, I'm not. I can continue tracing these back. And for how long could I do that? Well, that arrow is going to go on forever. So forever. So what you'll notice here again is we are going to be able to trace a point back to every single spot on that x-axis. So our domain would go from a negative infinity to a positive infinity, and both would get parentheses. This goes left forever and right forever. But notice again how every single time we are imagining tracing these points back to that x-axis. Now, on this one, let me make sure you're clear about the graph. This is actually the y-axis. And this vertical line right here is your graph. So this vertical line over here at the right is the graph. Now, we're going to take the points on that vertical line and trace them back to the x-axis. So if I choose this point on my vertical line, it goes back to this spot on the x-axis. If I choose this point, it goes back to the same spot. This point, same spot. This point, same spot. And if I move down here, trace back to the x-axis, I'm going up to the same spot. So notice, this goes up forever, he'll keep going, but even if I start here and trace back to the x-axis, I'm always going back to this one spot. So this number right here is the only number in the domain for this function, because all points on this graph trace back to that same spot. That number is, starting from 0, 1, 2, 3, 4, 5. So this time you're not going to write an interval, and you're not going to write an interval because you don't have two numbers, you only have one. The domain of this function, this graph, is just 5. Because all points trace back to 5 on the x-axis. Okay, let's look at just a couple more. Make sure you've got this. Notice we have a graph here with arrows. This arrow is going to keep doing his thing over here. So he's going right and he's going up. And notice this arrow over here, he's going to keep going. He's going to the left and he's going down forever. So again, and let me highlight my x-axis. Just feel like maybe that'll help you see it a little better. If I take the points that are on this graph So if I go to the graph and I go to the x-axis, notice I started out over here kind of in the middle at 0, and then I started going to the right, and I want you to notice that you would be able to trace this graph back to every single point on the x-axis. He's going to keep going to the right. So how long would I be able to do this? Forever. So I'm going to positive infinity on this side. On the other side, if I start over here, start moving to the left and tracing the points on the graph back to the x-axis. Notice that even when I reach the end here, that x-axis can keep going and I can keep tracing because that graph's going to continue on. So negative infinity on this side. So the domain for this would be negative infinity to infinity, parentheses on both. All right, one last example. This is the last one we'll do. And I want you to notice this time that we have a dot at one end and we have an arrow at the other. That means that this is going to continue on. So it's going to the right and it's going down forever. If I want to determine the domain, the x values, then same thing we've done every time. Take a point on the graph, trace it to the x-axis. Another to the x-axis. So just keep moving over a little. Starting from the graph, go to the x-axis. So I'm moving to the right now. And notice, because this graph is going to keep going, because of that arrow, that I would be able to continue tracing new points back to that x-axis forever. So on that side, I'm going to a positive infinity. On this side, though, I can keep taking my points on the graph and tracing back to the x-axis. And when I get here, I can't go any further because the graph stops there. So on this side, right there is where the domain is going to begin. No arrow, so that's not going to keep going. So that's -1, -2, -3. So when I do my domain on this function, I'm going to start out at -3 on the left and go to infinity on the right. At -3, there is this closed dot, so x can be -3. And for infinity, I use parentheses. So when you're trying to find the domain, visually, what you need to do is look at that x-axis and start tracing your graph. Trace each point on the graph to the x-axis and see what numbers are in use. Every point that you can trace back to the x-axis tells you where those x values are going to be. Like I said, I expect questions on this. And for those of you who are trying to do this at home on your own, I know that's a little tougher for you. And my time during the day is going to be a little more limited now that we are back in school on this hybrid schedule. But if you will email me and let me know you got a question, I'll get to you as quick as I can after school. Wednesdays are still open for me, so we could Zoom then to talk about it. For you folks who are B students doing this on Monday, you will have the opportunity to ask about it when you come to class on Thursday. Okay, so, but still feel free to email questions if you need to. All right, so finding domain, you're finding all the x values. So take your graph, trace every point on it back to the x-axis and see where they land.